Alibaba Qwen had a lot of releases recently. One among them is Qwen3-VL, their most powerful vision language model in the Qwen series. So this flagship model, Qwen3-VL 235B A22B, is now open sourced. It is available in both Instruct and Thinking version. The Instruct outperforms Gemini 2.5 Pro on key vision benchmarks. Thinking achieves state-of-art performance on multimodal reasoning tasks. So this is a 235 billion parameter model with 22 billion active parameters. Now, what are the key breakthroughs? So this model can be used as a visual agent. It operates GUIs on PC, phone, understands buttons, call tools, and completes real-world tasks. It can do visual coding. It can transform screenshots into code. Through basically HTML, CSS, JSS code, it can generate. What you see is what you get development. That is what they're saying over here. It has 256K plus context, scalable up to 1 million, supports 2 hours videos and multi-page long PDFs. Support for 32 language OCR with enhanced robustness for blurry, tilted or rare characters. It has advanced spatial reasoning, 2D relative coordinates, 3D grounding, occlusion handling, and perspective understanding. Occlusion handling. It has thinking mode, leading performance in STEM math, enables deep causal reasoning, and its text capabilities rival top tier LLMs. So if you look at the performance of this particular model in the benchmark scores over here, it does better than Gemini 2.5 Pro in some of the benchmarks, or majority or most of the benchmarks. It is close to GPT-5. It does better than GPT-5 in some of the benchmarks, right? That is what they say over here. So we can actually test this model on QwenChat, which is what I'm doing. So the very first thing which I wanted to show you was the code generation capabilities. So basically I took a screenshot of this page and gave it to QwenChat over here. So I have selected the non-thinking instruct version over here, Qwen3-VL 235B A22B. You can also select the thinking model also by selecting this model over here, and then you have a thinking button over here. You can enable it. So I said convert this image to HTML code. It actually did this conversion. It generated HTML code basically for this screenshot, right? So this is a screenshot which I uploaded, and when I copied the code and I opened it on Chrome browser, this is how it looks like. Very close to this page. Okay, the aesthetics is not there. Some of these, this is the live page, right, with functionality. That functionality is not present, but it is able to create, a very similar page over here. You see messages, right? You see these messages, and then you see this part. You see the profile over here and other things. So it's able to do all those things over here, and it is generated code for this particular screenshot of this particular page. So it's done an excellent job over here. Okay. Now, if you were to look at its OCR performance, I gave this complex newspaper layout, basically this newspaper image, and I asked it to decipher this particular newspaper image, all the news in the image, right? And this is what it did over here. It is able to, do the layout analysis over here properly, and it is able to pull out all these important news, headlines, plus whatever is below the headlines. It is able to summarize over here, and it is able to give the output properly. Okay, so that is what, when I looked at whether it has covered all these things, for example, like business as usual, right? It's actually this particular part, business as usual by Uni. So it is able to pick up that as well over here. All right, commentary on how businesses are adapting to post-pandemic norms. So it is able to do a lot of these things properly over here, OCR and other things. Another OCR use case is this. So this is a little bit of a complex image. So if you look at this particular image, there are two charts over here. They are very blurry. Even I am not able to read out some of these things. If I zoom in also, it is not that clear, right? 15 to 22% average body weight reduction in clinical trials. So you have this low blood sugar risk. It is very blurry. But when I gave this image to OCR over here and I asked it to do the OCR, it has done a good job over here. It says that this image is a satirical infographic promoting the diabetes weight loss medication. Overall theme and tone is this: it is sarcastic, it is deciphering this thing. See this: weight loss effectiveness 95%, 15 to 22% average body weight reduction in clinical trials. So it is able to pull this part 15, it could be 13 also, but I think it is 15 to 22% average weight reduction in clinical trials. This is 84%, this is 85%. Somehow it says both as 85, 85. Okay, small error over here, but it is able to do a lot of text OCR on this particular chart. Right, dosing convenience. If you look at this, once weekly injection improves medication adherence. You see that part over here. Once weekly injection improves medical adherence. So it is doing it properly. Now it is also doing the orange graph. These graph bars also: hypoglycemia, pancreatitis, thyroid, cerebral tumors observed in animal studies, human risk unclear. You see this part, human risk unclear. So it is actually doing a very good OCR, even if the images are blurry. Okay, this is a very the image is blurry over here. Even I find it difficult to read it, but it is able to do OCR on this page and give the output. Only problem over here is this is liver doc. It gives it as liver Joe. I'm not sure why that is happening. The logo liver Joe suggests is form of a content creator, likely a healthcare influencer. Okay. Otherwise, it's done a good job on this particular image, right? Then I did a video understanding. So I uploaded a video about Walt Gemma from Google, and I asked what is this video about and what are some key insights from this video. It's given a very good summary of the video, saying that this is about Walt Gemma. It explains the practical demonstration introducing Walt Gemma. What are the issues of current models, LLM models? They have a hidden memory. They have the capability to memorize and repeat parts of their training data. How is that overcome and things like that? What is Walt Gemma? Everything it is explaining very well over here. So this is video understanding, right? Now the next thing which I did was I gave it a metro image map. So this is a image of Delhi Metro, basically Delhi Metro map. So what I do over here is that I give this to vision language models and I ask it to navigate from a station called Tekri-Kalan on the green line to a station called Faridabad Old on the violet line. I've seen only Gemini 2.5 Pro give me correct answers for this question. So there are two possible routes. One is an interchange at Kirti Nagar and then an interchange at Mandi House. So you have the green line, blue line and violet line, right? Another one is you take the green line, go to Inderlok, take the red line and then the violet line. Kashmir Gate and Inderlok are two transfer stations, interchange stations to navigate for Tekri-Kalan to Faridabad Old. So I ask it as Old Faridabad. So most of the models mess up this. Even it's the same with Qwen3-VL. So when I ask without thinking first, it says take green line, yellow line, violet line, walk or local transport. It kind of says that go to Dwaraka sector, go to Kirti Nagar, Inderlok, head to that, go to Kirti Nagar, take the green line, okay, then take the yellow line. I'm not sure why it tells to take the yellow line over here because there is no yellow line at Kirti Nagar, right? There is no yellow line over here. The yellow line is somewhere over here, okay? So it kind of messes up this part and then it's a mess, okay? So I enabled thinking to see if it makes any difference. It says go to Punjabi Bagh East, switch to pink line. Now the pink line, there is no interchange over here at Punjabi Bagh West. The interchanges are clearly shown over here. Okay, it thinks of this as an interchange and then it says you go like this and somewhere on the pink line you go and change, which is also wrong, right? So for this particular use case, none of these models actually work, right? So it says pink line southern extension. This is the Neelam Chowk. That is the last Bata Chowk. That is the last stop. Basically, it says something over here. It kind of confuses everything. Okay. So this model also fails on this metro map interpretation task. That is what I've seen. Then I gave the video again and I said that, okay, can you, with thinking capability, I said, can you create an infographic? So here is the thinking trace. It says I need to create an infographic based on the video's content about AI's privacy problem. So the video covers these things. For this, I'll create the color design like this, notebook LM branding. That is what was available in the particular video. So then it goes to create this markup infographic. Okay. So it has done a good job over here. That's what I would say. So this is a very interesting model. It's got excellent performance on OCR. It is able to understand videos. It's able to generate code based on your screenshots. It has 256K plus context, right? It is scalable up to 1 million parameters. It's available in API. It is available on Qwen chat for free for you to try it out. The model is present on Hugging Face. If you go to the Hugging Face page, they explain more about some architectural improvements which they did over here compared to the previous Qwen 2.5 VL. So you can check out those things, right? They also have, I'm not sure whether they have a technical report somewhere. They have a blog, okay, so which explains more about this particular model, what they did in terms of key highlights and model performance. They talk about, do they talk about architectural improvements over here? Let's just see. They talk about training times, multilingual OCR. No, they talk about model updates over here. Yeah, small part they talk about, what are the things they did as improvement. So if you look at this particular model architecture, it has a vision encoder and a language model, which is Qwen3-LM. And then they talk about some improvements like interleaved M-rope. So this is embeddings, positional embeddings. So they talk about that over here. They talk about something called as deep stack technology to fuse multi-level features from VIT, from the visual image transformer, enhancing detail capture and text image alignment accuracy. So they talk about that over here. Following the core idea of deep stack, they shift from conventional multimodal large language model practice of injecting visual tokens into only a single layer to injecting them across multiple layers of the large language model. So it's kind of how the visual features are injected into the large language model. And what they are saying is that this multi-layer injection approach enables finer grain visual understanding. That is what they are talking about. Then they also upgrade the original video temporal modeling mechanism to T-rope, a text timestamp alignment mechanism. So this adopts an interleaved input format of timestamp video frames, enabling fine-grained alignment between frame-level temporal information and visual content. So that's what they are talking about. So the model capabilities, visual agent. So they have some demo example Android use over here, some videos. So you can actually check out these videos. Think with images. So you can upload an image and you can ask like, okay, let's look at this, what it is. Okay, so where can you buy a particular equipment? Which brand is this? Is it worth buying? Those kind of questions, and it is able to give an answer regarding that. So this is more about Android controlling GUIs. I'm not sure why this is not playing. Okay, so it's able to post on X, search for Musk in X and go to his home page to open the first post. Okay, so it's able to do screen control and those kind of things. Code programming, we saw this, we uploaded a screenshot and it gave the code, right? Then this is about spatial understanding. Okay, so given an image, it is able to find out which is the relative object, where farthest placement object in this image, understand what are the objects and things like that. 2D, 3D grounding, locate every instance that belongs to the following head, hand, man, woman classes. So it's able to do that object detection kind of thing in this particular and give a JSON output. Right, universal recognition, identify characters, identify celebrities, food, plants, animal, car brands, and anime characters. Yeah, creative writing. So these are some of the use cases which they are showing over here. STEM and multidisciplinary problem solving. So you can give an image of a problem and then you can ask it to solve it. Right, it's able to do that. Complex instruction following, complex document understanding and general parsing, multilingual OCR and visual question answering, multi-image, multi-round dialogue. So you can go and check out this video understanding, which is what we saw over here in one of our videos. There is also API usage as well. So you can check out this particular blog page to understand more about Qwen3-VL. So this was a short video on Qwen3-VL and its capabilities. This is definitely a very good, powerful vision language model, giving competition to other models like Gemini 2.5 Pro or GPT-5. So this is a very good release from Qwen. This is open weights. So if you have the infrastructure, you can download the model and deploy it. Otherwise, you can try it on Qwen Chat, their API. I hope this video is useful to you. If you like the video, please like, share, subscribe to the channel. See you in another video.